Well, how does MCast forecast those first cold days? I always like to start with a pretty simple graph here where we've got, again, our daily average temperature on the x-axis and our demand on the y. This is fictitious data that we've put together for, that we're calling system. And this is a pretty typical way to view gas demand data. But for the purpose of this talk, we're not really caring too much about, well, all days. We want to focus on, forecasting those first cold days. I've got my heating degree day calculation here, but the way we're going to define our first cold day is going to be days where the HDD, the heating degree day, is greater than 0, and the prior 2 days do not have any heating degree days at all. So this is that same data. I've flipped the graph around. The x-axis is now heating degree day, or more accurately, 65 minus the daily average temperature. And then I've highlighted our first cold days here in yellow. We're going to fit a model to that. So this green line represents a pretty basic gas forecasting model where our demand equals our base load time, or our base load plus our heating degree days times our use per heating degree days. And this model does okay. It's going to get 12% error on all days, but it's going to do pretty terribly on those first cold days with a 25% error, which is not very good. And we can sort of see why that happens if we look at our graph here, where our green line is well above where the majority of these yellow points are. So how can we make this better? Well, the first way we can make it better, and this is something we do for all of our modeling, is we can use multiple heating degree day terms. And it's part of why we look at those HDD 55, is because we use it as part of our modeling, because we know at temperatures below 55 degrees, we've got a much more linear fit. Actually, if I hop back here, you can kind of see that. 55 degrees is going to sit right around here. You can see that by the time we get to there, we're much more linear relationship to the right of that than this chunk here, where we're maybe not as linear. That's part of why our green model is not doing very well. But adding this second heating degree day term helps our model in a bunch of ways, largely because if we've got just the one heating degree day term, essentially have a lever that we can work with. But if we're doing two, we've got 2 points, and it gives us a little more freedom to move around. And so with those extra degrees of freedom, we're going to fit better on shoulder days, so that's going to help us a little bit on cold days. And not as important for this talk, but generally speaking, this does better on design days. In addition, we're going to give ourselves another degree of freedom by adding a cooling degree day term. And so I've plotted this 4-parameter model over our data set in this gray line. You can see, we're tracing along. We've got this, two places where it bends, and we've got a slope here going out on the cooling side of things. And overall, this definitely improves our forecast. On all days, we've dropped our error down to an 8% error, but we're still not doing great on the first cold days. An 18% error is certainly better than the 25 that we were getting before, but it's still not amazing. And if you look at our graph here, you can see why. We're still fairly wildly over forecasting um, the average first cold day. And that's obviously gonna drive up our error. Um, so what can we do to do better here? This is where our fifth parameter to our model comes in. So um, essentially, what we're doing is we're taking the mean or the average of our HDD 65 and HD 55, and we're saying, well, today's average heating degree day minus yesterday's heating degree day. So we're adding this additional bit of information to our model. So our model knows, well, how much warmer or colder is today than yesterday. And essentially, this is going to allow us to subtract out some of our forecast because yesterday's heating degree days were less than today's on these first cold days. This is going to help out our forecast a lot, but it specifically helps a ton on those first cold days. And so I've plotted that in the red. If you look at our results here, it's dropped our error from 8% to 6%, and our first cold days have been cut in half from 18 to 9.3, which is a big improvement. But if you look at the graph itself, you might be skeptical of those results because this red line is still sitting well above those first cold days. And the reason for that is because this red line is kind of a slice of a 3D model. We're only plotting today's daily average temperature versus demand. So this line here is really more like, well, what if today's demand and yesterday's demand were the same? This next part, it's a little bit easier if we zoom in. But if we instead plot, well, what does this line look like if yesterday's heating degree days equals 0? So yesterday's heating degree day equals 0, and then this, represents how many heating degree days there were day of. Well, now we've got a nice line that fits right through the middle of those first cold days. And that's why, using methods like this, we're able to forecast well when those first cold days happen, where a simpler model probably is going to over forecast most of the time. We're not done there. We apply a couple of other treatments. First one is we weight the first cold days more heavily. Well, we weight a lot of different types of days more heavily when we're doing our modeling. So we don't get a ton of cold days, like super cold days, and we don't get a ton of these first cold days and a bunch of other um, more unusual situations. And so we weight those data points more heavily so that our models can forecast better on the rarer events rather than doing really well on your average day and then doing poorly on odd days like these first cold days. In addition, there's a little bit of MEA secret sauce going on here, in a similar way to how my presentation's been redacted a little bit. There's in a similar way to how we were looking at, well, how does yesterday's demand affect, or yesterday's temperature affect today's demand? We can also then look at, well, what did 2 days ago's temperature? How is that affecting? And what is the cumulative effect of, well, 3 days ago and 4 days ago? And, as that thermodynamics of, you know, the temperature through walls, of homes comes into play. And in addition, we do some other modeling stuff that helps us across the board, like accounting for day of week and day of year, etc. And with all of those things, we're able to cut down that error further. For this particular area, we're cutting our error on all days down to about 3%, and on those first cold days all the way down to 4. Um, I will, note that all the metrics shown in this presentation about how well these models performed is on in-sample testing and on perfect weather, or, more accurately, observed weather. So this doesn't account for, well, how did the weather forecaster do, or other things like that that are going to bring our error up. Although, notably, these are just for our linear regression model, not for the linear regression and ANN and all the ensembling that we do as well.